What's up, scholars? Today we're talking about the applications of trig. Let's say you come upon this really tall tree and you're like, man, how tall is that tree? I wonder. Remember you learned trig in high school and you're like, gosh, I wonder if I could use my trig. I think I probably could. I think if I could know how far away I was from the tree and the angle of elevation I look at the top of the tree, then I could see how tall the tree was using, what was that one? Opposite and adjacent, tangent. Oh yes, that sounds great. So you walk a known distance away from the tree, which is the same as the length of this bottom of this right triangle. And you look up to the top of the tree, and you have a special device that we're going to make together here in a second, which shows you the angle of elevation you need to spot the top of the tree. So you have this known distance that you're away, you know the angle of elevation, and you can use that to calculate the length of this side of the right triangle. And then to find the whole height of the tree, you've got the side of this right triangle that you calculated using this known length that you walked away from the tree and this angle of elevation, plus however tall you are. Doop, doop. And that's what we're going to do today. Again, the total tree height is going to be the opposite side that you calculate using tangent plus your height. How are we going to find the opposite side using the tangent? Well, if tangent of some angle theta equals opposite over adjacent, then the opposite side, put more letters there, opposite side is going to equal, if I multiply adjacent on both sides, the adjacent side times the tangent of the theta. Again, the adjacent side will be the known distance away from the tree, the adjacent side, and the theta will be this angle of elevation that we calculate using what's called a clinometer. Okay, so here is a very rudimentary clinometer. Remember, meter means measure, so we're measuring the incline with this guy. We've got a protractor, we've got a straw on the top, we have some sort of string, and a weight, which I'm using a paper clip. So the idea is you hold this up, you sight the top of whatever you're looking at through the straw, and as you rotate this, gravity will pull this perpetually down, and this will tell you your angle of incline. So if I'm starting here, this would be 0 degrees, even though it's going through my 90 degrees, because it has not inclined at all, so that's 0 degrees. And then as I rotate, that would be 10 degrees, 20 degrees, 30 degrees, 40 degrees, and so on. So you may or may not have a protractor. If you don't, I'm going to show you how you can make one. You may or may not have a straw. If you don't, that's okay. You'll just sight the top of the protractor that you create. Lots of different options for string. You could use string, you can use dental floss, you can use a rubber band that's cut, and then obviously plenty of options for weights. Anything that you can tie your string around that's heavy enough to hold the string a little bit taut-ish. Like I said, if you don't have a protractor, we're just going to make one. Take a piece of paper and cut out to the shape-ish of a protractor. You want some sturdy paper, or maybe 2 pieces of paper glued together, or maybe some junk mail that's like that poster card. Actually, that would be a great idea. I get plenty of that stuff. And then we're going to have to mark the angles on it. So we know that, here's my center. This is going to be 0 degrees. And if I rotate up here, the highest we would ever get to would be 90. So we want to do our best to make from 0 to 90 in, let's say, at least 10-degree increments. And there we go. There's my 0, right in the center. Yep, I actually split it in half. Not very well the first time, had to scribble that out. And did 10 to 90. There you go. Then we attach our straw if we have one, and definitely our string and weight down the center. We made our angle measurer, which we're going to use to measure the angle of incline. If you don't have a measuring device to measure how far away you are, you can try to use your step length. So a quick internet search for average step of a person gave me this nice little chart. It's got men and women's strides. Seem to not be any different here. I'm not totally sure why it would make much of a difference. Doop a doop boop boop. There's that chart. There we go. There we go. Okay, so you can find your height on here in feet and inches, and find your stride length, and use that if you don't have a measuring tape to measure how far away you are from this tree. So I am 5 feet 11, so my average step is 29 inches. Let's use that for an example. And my step distance at 5'11 is 29 inches. I converted my height into just inches, because that'll be easier for me. I'll convert everything to inches and then convert back at the end to feet. So let's say I take 10 steps away from this tree. So my distance here is 10 steps. My steps are 29 inches. So my adjacent side is going to be, well, that was pretty easy, 290 inches. So 10 steps would equal 290 inches. Let's say, I'm totally making this up, my angle of elevation is 30 degrees. Theta is 30 degrees. So let's find the adjacent side of this triangle, and then we'll add my height of 71 inches. Nope, not adjacent. Opposite side. I made that mistake last time. Opposite side. So we know that, where should I write this? I think right here would be fine. Tangent, right on top of all my writings. That's great. Tangent of theta is opposite over adjacent. We're going to solve for opposite, so let's get that by itself by multiplying by adjacent on both sides. So I've got the adjacent side times tangent of theta is the opposite side, which will be this chunk of the tree's height. So the adjacent side was 290 inches times tangent of 30 degrees will be the opposite side of this triangle. It's going over my internet calculator. So I typed in equals 90 times tangent 30 degrees. Make sure you put degrees in there, otherwise they will assume radians. So that's going to be 167.43. Got it. So then we said the total tree height is going to be that opposite side plus my height. So 167.43 plus 71 is, where's my calculator? I don't feel like doing it. 167 plus 71, 239. 239.43 inches. I don't know what that is. Let's go convert it to feet. Just divide that number by 12. 239.43 divided by 12 is 19.95. 19.95 feet. So this tree is almost 20 feet tall. Et voila! So your mission is to not only take notes over how to use tangent to find the height of some object, but also to make a clinometer. Both of these should be done before the beginning of next period. So when we come to class, we can find the height of some objects in the outside world. That's it, scholars. Love you so much. Have a great day. I'll see you next time.